Hello, this is John from caveofprogramming.com, and this is the fourth in the series on multi-threading in Java from Cave of Programming. And in this tutorial we're going to look at using multiple locks and synchronized code blocks in your application. So I've got an application set up here with it has a main method, and I've got a really simple class called worker, which also has a main method, just a public void main method. And my main application is just creating a new worker object and running its main. So the bottom line is, if I run this now, this is just outputting hello, because this method's being run. Now I'm going to give worker I'm going to give it some private instance data. I'm going to give it a private, just for fun, let's make this a list. So in previous tutorials we've looked at incrementing integers from different threads, and let's take a look now at kind of problems you get with lists. So let's make this a list of integers, and I'll call this list1, and I'll set it equal to a new list of integers like this. A new array list, that is. Let's make this an array list, and I'll add the inputs, the Java util list, and let's put a semicolon there. And let's have another one of these, a list2, and I'm going to give this worker object, I'm going to give it a couple of methods. I'm going to imagine that worker does some processing, and the processing can be broken down into stage 1 and stage 2. So let's have a public void stage 2. And now stage 1 is going to do something with this list 1 here. So let's just have something to do. I'll just declare a random number generator up here. So this doesn't really have anything to do with multi-threading, but I'm just trying to make this kind of as semi-realistic as possible. And let's imagine that stage 1 it does some kind of a calculation which takes a bit of time, or maybe it gets some information from somewhere. To simulate that, I'm just going to have a thread.sleep for 1 millisecond, just to slow the program down a bit, and just to simulate going away and getting some information from somewhere. And let's then imagine that it adds that information to list 1. So it says list1.add, and I'll just use random.nextInt. So I'll add random numbers here to this list. But you could imagine that this is going away and pinging a machine, and although it would probably take a bit longer, and adding the ping time to a list, for example. Now stage 2 here, let's imagine that does something also similar, except that it adds stuff to list 2. And now I'm going to add a process method that's going to do all the processing. So I'll call it public void process, and this is just going to call stage 1 and stage 2 in a loop. So let's say that it has, we could try 1,000 iterations of this loop, and so let's say I++ here, and for every time it goes around the loop it calls stage 1 and stage 2 like this. Now let's try running this, and what I'm going to do here is I'm going to put some code into my main method that times how long this processing takes. So I'm going to say here long start equals system.current_time milliseconds. There we go. And at the end I'll say long end equals system.current_time milliseconds, and I can output the duration here. I can say time taken, and I'll add on there end minus start. And let's also output the list sizes just for fun. Let's say list 1 plus list 1 dot size, and I'll say here list 2, and let's output list 2 dot size. Okay, now in the middle here, I'm going to call, between start and end, I'm going to call process. And so the process method will iterate 1,000 times, and every time it goes around the loop, it will call first stage 1 and stage 2. And stage 1 is writing to the first list, and stage 2 is writing to the second list. Now if I run that, we'll expect it to take, let's see, so it's taken roughly 2 seconds, just a little bit longer, which is what we'd expect really, because we've got a sleep of 1 millisecond in each stage, and we're calling stage 1 and stage 2, so there's 2 of them, that makes 2 milliseconds, and we're doing that 1,000 times, so that adds up to 2 seconds. Now you might think, if let's say that what we're actually doing here is, it could be pinging a machine, or I don't know, processing some file or something, and you might think, well, I could speed this up a lot by doing running multiple processes at the same time. So I could have multiple threads, and each one could run process. And actually in the next tutorial we're going to start looking at thread pools, which is ideal for this sort of thing, where you can create a whole bunch of threads to work through whatever work you have to do. But here, let's just stick with creating a couple of threads. So I'll say here, new thread, and I'll pass this an instance of runnable. And this is just a very slight variation on what we've seen in previous tutorials. And I'll implement the runnable method in here, and in run, I'll implement the run method, public void run, and in run I'll call process. And now I can start that just by calling here start. So Eclipse is not being terribly helpful. If I press a dot, and then I can call start, there we go. So this is a very minimalist way of running a thread, basically equivalent to declaring a variable and pointing it at that thread, and then calling the variable dot start. But you can just do it in very few lines like this if you want. Now I'm going to have another one. Well, at the moment, let's just check that actually does what we expect. So this should take 2 seconds to run roughly. In fact, I need to wait for that thread to finish. So actually I am going to have to create a variable here. I'm going to say thread t1 equals, because I need to call t1.start, and then I need to call t1.join, because I need to wait for that thread to finish before I can get any meaningful results about my processing. So let's try that, and now we'll see. So that took 2 seconds as before, just as we'd expect. But now we can run 2 of these threads at the same time. So if I copy that, and I could have t2 there, and I'll say t2.start, and in here I also need to wait for the second thread to finish as well. And now if I run that, we'd expect that it would still take 2 seconds, because I know that I'm not putting a huge load on my computer, because actually all it's doing is sleeping. So CPU load is not going to be a factor in slowing this down. And I'm kicking these off at the same time. Let's move this down here to make it even more obvious. We're running these 2 threads simultaneously, so in theory it should still take 2 seconds. And let's have a look at what happens when we actually do try to run it, and we'll see this is going to be a bit of a nightmare. So we try to run it, and well, that actually ran fine, except that we've not got 2,000 items in each list. Some of them have gone missing. And if I run it a few times, well, actually another time was enough, it turns out. We're going to get these array index out of bounds exceptions, and these are just the normal problems that you expect if you try to access shared data from multiple threads. We've looked at that problem in the last tutorial in the context of incrementing an integer, but of course you get the same problems with threads interleaving if you're trying to write to a list, because writing to a list is not a single step operation. Multiple things have to happen within that list, and if the threads interleave, it causes all kinds of crazy problems. So we know that we're going to have to make these methods synchronized. So I'm going to make this synchronized, and I'm going to make this synchronized, and we think, okay, now we shouldn't see any, the list should have the right number of items in them, and we wouldn't expect to see any funny exceptions. So if I run this, and would hope that it would take 2 seconds, but in fact what happens is that it's actually taken more like 4 seconds, although the lists are now the right sizes, and I can merrily run it as often as I want without getting any exceptions, and they will always have the right number of items in them. But it's always taking twice as long as we expect. So what's the reason for that? And the reason is that as we've seen, I think in the last tutorial, when you call the synchronized method, that is going to acquire the intrinsic lock, or the monitor lock you could call it, of the worker object here. And so if one thread runs this and then another thread tries to run it, the second thread will have to wait to acquire that lock until the first thread releases it by exiting this method. And that's what we want, that's fine, and it's the same for this method. We want another thread to have to wait to run this method if a thread's already running it, and that's all good. But the problem here is that there's only one intrinsic lock for the worker object. So if one thread's running this method, another thread will have to wait to run this method, because if one thread's running this method, it's acquired the intrinsic lock of the worker object, and this another thread, a different thread, can't then run this method because it also has to acquire the same lock to run this method. And yet these methods are independent. They don't write to the same data. That's the crucial thing. This thread writes to list 1 and this thread writes to list 2. So really what we want is a system whereby no two threads can run this method at the same time, and no two threads can run this method at the same time, but one thread can run this method while another thread is running this method here, because they're not writing to the same data. So we can do that by creating separate locks and synchronizing on two locks separately. And we're going to look at the reentrant lock class later on in this series of tutorials. But here I'm going to show you a simple way of doing it just by using the object class to lock on. So I'm going to create an object here called lock1, which I'll set equal to a new object, and I'll create another object called lock2. And I'm going to say down here, instead of having synchronized methods, I'm going to have synchronized code blocks. So I'll say in here synchronized, and I'll synchronize on lock 1, and I'll put all this code in this code block. Or the sleep doesn't really need to be synchronized, but let's imagine that that's doing stuff that we do want to be synchronized. So I'll put it in there, and it's going to be the same again here. So I'm going to have this synchronized but on lock 2, and I'm going to put this code in the synchronized code block. Now, and we'll delete the synchronized from the method header there. Now, synchronized code blocks work similarly really to synchronized methods, except that now two methods can run this method at the same time. But if two threads can run this method at the same time, but if one thread's already entered this synchronized code block, the second thread will have to wait until it can run the synchronized code block. You'll have to wait until the first thread has released this lock by exiting this code block. But since we're locking on different objects, one thread can run the stuff in here while another thread is running the stuff in here. Because to run this stuff you have to acquire the intrinsic lock of the lock1 object, and to run this stuff you have to acquire the intrinsic lock of the lock2 object. So we've achieved our purpose here. One thread can run this while another thread's running this, but no two threads can run this at the same time, and no two threads can run this at the same time. And now if I run this, we'll see that now we're back down to taking roughly 2 seconds, because our processing, which takes approximately 2 seconds, now we can run 2 lots of processing simultaneously without having issues about waiting on one lock. And by the way, you might wonder why I didn't lock on the lists themselves, and I think that would work, but it's good practice to declare separate lock objects, because otherwise you can give yourself a headache. For example, if these were numbers that I was incrementing and I tried to lock on the actual numbers themselves, you'd never quite know if Java had optimized your variables to point at the same number behind the scenes, if the value of the number was the same. So the bottom line is, you can complicate things if you try to lock on the actual object that you want to write to, and it's better practice to declare separate lock objects here to avoid any possible confusions. So that's it for this tutorial, and in the next tutorial we'll go on to look at thread pools in Java. And if you go to www.caveofprogramming.com/courses, you can find there more free Java courses as well as some paid courses. And all my courses include at least some free videos, and you can find courses on web programming with servlets and JSPs, and Java Swing and Beginners Java and Java Collections, and starting in about November 2012, hopefully also some an Android tutorial series. So that's it for this tutorial. Join me again next time, and until next time, happy coding.